Yo, I am a bird watcher who is super keen on understanding the weather and weather forecasting in order to have as much fun as possible when I'm in the field. Over time, I've discovered a bunch of websites and other tools that I utilize to see what's going to happen with the weather or learn from weather patterns. And I've compiled them on a website, link below. And I thought it'd be fun to go over them in no particular order and just provide some thoughts, some nuance, some things that I use in order to make birding weather predictions. I'll kick off with the Holy Grail, which isn't really a weather tool. It is a birding and weather tool combined, Birdcast. They have two famous products, the live bird migration map and the bird migration forecast map as the other one. Live bird migration maps uses radar, real-time live radar data, and it shows you areas of heavy movement with the brighter colors, as well as sort of an average of all of the signatures that it's picking up, the direction that they, as an aggregate, are moving. So it's a super cool way to visualize radar data where it's focused on birds instead of rain or snow, and also the bird migration forecast maps, which involve a computer output called the North American Mesoscale model. It is a calculation of the short-term local fine scale weather prediction that is then analyzed by an AI algorithm that has been trained on all of the radar data that exists on bird migration, rain, snow, as well as like temperature data, I assume wind data. I don't know all the data they plug into it, but they've trained an AI model to understand all the times in the past that birds have been seen on radar and what the weather was like for those dates to then make this forecast of what bird migration is going to be like based off that computer model's estimation of what is going to happen with the weather. That model runs 4 times a day. I'm not sure how, oh yeah, so it looks like they update the maps on the same schedule with the same data, and it's super cool. And it's kind of the culmination of some of the things that I'm going to talk about, but is worth mentioning right off the top is this holy grail that is now available to us when looking at weather and birds and predicting what's going to happen tomorrow. So there's a bit of an order to the tools page, but also it's not particularly critical to go through it this way. But I thought it would be good to start with windy.com since it is a weather data visualization tool that a ton of birders use, and there's some really great elements of it, such as how easy it is to sort of understand what's going on. Using wind as an example, I love that it shows you the little arrows. It also has color to highlight the areas of stronger wind. Something I use Windy for all the time is how easy it is to see how the direction of the wind and the intensity of the wind changes as you move up off the ground, with the 850 millibar height, kilometer and a half up, being a popular one that birders look at to see what the wind direction and temperature is like, where the birds would be migrating, if they're migrating at night in particular. But I also think there's some big caveats with this website that are not always known or represented when people use the data. And that has to do with the fact that these are model outputs. These are calculations from a numerical computer algorithm run on supercomputers that, especially with the free version of Windy, only update twice per day. And being a numerical calculation, as you move farther out in time, especially now that they let you go upwards of 2 weeks out, compounds any potential inaccuracies or mistakes. So as the calculation deviates from what we would end up actually seeing, the differences are compounded even more and more, so the error increases with time. So once you get out 8-9 days into the future, this is the Europeans' calculation of this moment in time from its most recent run that's been uploaded to this website. When it runs again 12 hours later, as those situations change and as any potential errors, or even if it's right in a with better accuracy than the last run, it's going to calculate a different outcome each time. And that's easy for me to visualize by just clicking on the different models, such as the GFS, and you can see the difference in predictions for clouds. If you do wind or wind direction, you can see that it'll change quite a bit. So not only does each model run of the same model change, but then you can see the differences between each one. So just because it shows you a certain calculation 14 days in the future doesn't necessarily mean it's going to come to pass, because the models are going to be different each time and be less and less accurate the further you go. And there are a lot of other caveats with model data, such as what the model is designed for. So the Euro, the American, and the German ICON model are pretty good at medium range weather forecast, whereas the NAM, the high resolution rapid refresh, and the Canadian mesoscale model are designed for a finer resolution, shorter time frame of weather calculations. But because it's such a fine scale, their accuracies actually grow a fair bit as you even move out to like a 2-day difference. Or another famous one is the North American mesoscale model isn't programmed to understand hurricanes. So anytime a hurricane appears within its range that it's calculating, it does really wacky things. So I wish there was a little more understanding around this is not a forecast, this is a numerical computer calculation that is subject to wild swings, especially as you move into the future with its predictions. But the visualization is incredible. I love that you can change the height. I love that you can easily switch from one thing to another to see positions of rain and clouds. Just gotta keep those big caveats in mind. Now that we've sort of covered the pros and cons of Windy, I'll show you my probably favorite website for looking at this model data, which is Tropical Tidbits. They have a lot of stuff, including a lot of hurricane forecast stuff, but just looking at the models here, you can more clearly see what the models are meant for. Global models being, Earth-wide, but also really focused on that sort of medium range, like 1 to 3 to 7 to 10 days into the future. European being really awesome. The global forecast system being really awesome. ICON not going as far into the future, but known for being reasonably accurate. This site does have hurricane-specific models. When I talked about the NAM not being meant for hurricanes, if there is a storm on the anywhere on the planet, but especially one in North America, which is where I tend to bird, these models are calculated to understand the nuances of hurricanes and how they're different from other weather. And they are in various resolutions. The mesoscale models, as mentioned, are meant for more of that like thunderstorm or local scale weather, not broad continental weather systems. It will show you that information and can give you a higher resolution as you zoom in than some of the global models. There's a lot more detail involved here. But just that understanding, of what the differences between the models are is important. But also, on this website, I think where Windy excels, and this one is a little harder to understand, is if I want to know what is happening with the weather at the height that the birds fly off the ground, you just have to understand a little bit more of what it is you're clicking on, such as that 850 millibar height wind map. I now know that that's the height that birds migrate at night, but it's not as easily laid out as it is on Windy. But with each website, there'll be some positives and some negatives. If you're a bird weather forecaster, I happen to particularly like some of the features on this website, such as this 850 millibar level that combines temperature with the wind, shown as wind barbs. So it's just kind of a example of the different variations you're going to get on different websites. One thing that I want to highlight that's a real new, exciting element to this website that I haven't seen incorporated to Windy yet is that you have access to some of the big AI forecast systems, which are totally different than the numerical calculation. This is actually a lot more like Birdcast, where they've just fed the history of all the weather data we've ever collected in terms of surface maps and frontal boundaries and temperatures into an AI model that then just predicts what's going to happen without all that fancy science, calculation, chemistry business. And there are pros and cons of each model, but from a birding perspective, it's actually pretty remarkable that on this broader scale, the AI weather models, this one only has the European. I'll show you another website in a minute that has the American version as well. But they're a bit more accurate than these numerical ones, which tend to jump around because each time a calculation is slightly different. It gives you a more dramatic difference from one run to the next. If I'm looking at temperature or 10-meter wind, it's kind of remarkable how accurate they are. So this website, Tropical Tidbits, gives you this ability to see at this time, so at 1 p.m. February 18th, this is 12 hours out, so the forecast should be fairly accurate. But I can go back to the previous run just by clicking that button. So 18 hours or 6 hours ago for the 18-hour forecast, which is the same time for 1 p.m. this afternoon. Every time I click that button, you can see how much the model changed its prediction from one run to the next. So you can see it thought it would be 26, 27 degrees Fahrenheit, where I live in southwestern Ontario, for a long stretch of time. So you can see it's starting to go up. So it's changed a little bit around 30 degrees. This is a 114-hour forecast from 4.5 days ago. So that consistency, as well as that reasonable accuracy that far into the future, seems to be better than what a lot of the numerical models have done. So the numerical models will jump around. This one, not so much. And I can actually visualize that too, if you ever want to get a handle on how accurate the models are, how far out into the future. This is the numerical European one, running off calculations. And it, as I click backwards on the wind maps, you can keep an eye on these pressure centers. You can keep an eye on the wind. When the distance is short, it jumps around a lot less. And then as we get further back in time, or have a forecast that's further into the future, you'll start to see these low pressure centers, or the intensity of these wind barbs will jump around on the map more and more and more. So where the storm is, where the rain will be, changes quite a bit as it jumps around more and more. So it's kind of cool to have that AI option available to us now. This Pivotal Weather website has the GFS GraphCast as well. It's a website I use less, but it's the place I go to if I want that model. This Polar Weather website has a lot of the same functionality. Again, it's not one I'm super familiar with, but it has some neat things like a blend of all the numerical models. So some people have found that, I click here, where's the blend? National blend of models. It blends the different numerical ones together into producing one forecast based on the likelihood and the overlap between all the models. That seems to improve the accuracy a little bit. And there are these things called ensembles, which every time a model runs, so this is the European, they also run a bunch of slightly lower resolution but slightly variable calculations. And on most websites, you don't really get to see what each ensemble says. You just get to see the average of them all combined. Whereas this one, as I go out into the future, it's showing you slight variations from the same model run from the different ensemble members. So you can see how some don't have a storm at all, some have a storm. This is only 138 hours out from now. So it's just kind of a neat way to visualize how windy might show you a map that looks like it's probably going to be set in stone and is really dramatic, but there is sort of some unknown involved with weather forecasting. And most ensembles seem to say there's going to be a snowstorm. It's not totally locked in stone. It's just a cool tool to keep in mind if you're trying to figure out which day you might want to be developing a cough or a sniffly nose in the future, if you want to be out for a really exciting weather birding day. So if all that computer weather model output nuance calculation stuff was a lot, there is a shining light here, which is the National Weather Service surface forecasts. I'll start off on the half-day to 2.5-day short-range version. It's super detailed, including locations of rain and snow, because we're not that far into the future, so the confidence is fairly high in what's going to happen. And it's a really cool way to just visualize where the precipitation is going to be, where the cold fronts are going to be. Tight isobars like this are stronger wind. Big spaces between tend to be lighter wind. But it's really good compared to the weather model data in that this is produced by a human being. It is not just a computer calculation output that changes from time to time. This is a person with expertise who is using all of those weather tools, including the computer outputs, to produce what they think is an accurate representation of what is going to happen. And it's not subject to the same wild changes that the computer models are. They also do this 3 to 7 day medium range forecast. Doesn't include the precipitation, but again, if you get a handle on the isobars, high pressure, low pressure, cold front, warm front, vibe. It's a fairly accurate, human-corrected view of what is likely to come to pass. And going even further out, they do 6 to 10 day and 8 to 14 day probability forecasts, where you're just looking at the likelihood of above average or below average temperatures, as well as above average or below average precipitation. And again, if you're kind of planning into the future of what might be on its way, it's a really good tool for that. I actually use it quite a bit. So kind of an interesting example here, given the date, but where I live in the Southern Great Lakes, some years we'll get warm surges of air in late February, which can provide the first big surge of spring migration, and people, can get excited about it. Whereas just using this tool, I have a reasonably high confidence that we're probably not going to get a February surge of warm air where I live. It's not in the cards this year. Carrying on, the marine forecasts. This is something I find I use all the time, because many a birder, if you're trying to hit a big, spectacular day, will head to shorelines for concentration effects of birds, whether it's water birds or hawk watching or fallouts. Usually shorelines will aid in that endeavor, and the weather on the shorelines of the lakes and over the water is actually a fair bit different over land. You can get drag on wind over land from buildings and trees, whereas the wind will tend to be stronger near the shoreline. You can get different temperature gradients from either the water being colder than the land or vice versa, or the sun can't heat up water as much as it heats up the land, which can cause different weather phenomenon. So I always want to see a focused weather forecast, usually only a day or 2 or 3 out, for what is expected to happen on the lakes. These are the Canadian forecasts. They're super easy and clear to read. And there's also the NOAA operational forecast system, which I almost always just use for wind. It doesn't have cloud data or anything like that, but you get these like high detailed wind barbs for the lakes, and you can see hour by hour, a day or 2 out, whether the wind should be increasing or decreasing, or whether that east wind that you see forecast is an east-northeast wind or an east-southeast wind. Having one for each of the Great Lakes is really awesome. And I do know that there are forecasts, marine forecasts or operational forecast systems for other coastal areas around North America. So be sure to see what may or may not be available for your area. And sort of tagging on to the Great Lakes and coastal areas is some of the snow and ice products, which can be of value in late fall and winter, or even early spring. The US one maps that I look at tend to be sort of lower resolution, but really easy to visualize, where there's snow and ice on the water. I was looking at these maps for the short-tailed shearwater curiosities of the past fall and how they ended up on the Great Lakes and other inland locations around when ice formed, in the Arctic Ocean. Other birding things that I'll use it for a lot is, I'll notice that as soon as a tiny bit of yellow ice appears on the coast on these maps along Hudson Bay and James Bay is when we start to see our first purple sandpipers in late fall in the Great Lakes. Another one I'll look at is when all of these northern lakes will freeze over. Is gulls and gull migration. Part of it seems to be tied to having access to fresh water to drink. So as all these lakes freeze, that tends to be when we get our big late fall, early winter arrival of gulls where I live. So lots of different things you can use the ice data for. The Canadian version, I'll pull this back because that defaults to the Great Lakes. But they have all ice forming areas of North America visible as sectors where you can get information for. Great Lakes are the ones I use all the time. Again, higher resolution, and where the US model just kind of showed some open water, some frozen solid areas. There is some nuance to that where it's really only these gray areas that are frozen solid. Even these red areas, which can be nearly totally ice covered, usually means that the ice is either moving or there are leads of open water. Anything that is just above 90% ice with water is covered on this map. So I always think of red as totally frozen, but in reality there could still be lots of available water depending on what kind of bird you're looking at. They're updated once a day. and these areas clearly have a lot of open water with ice flowing in them. When this was updated, we'd had a fairly strong west wind, so it seems like definitely some water opened up along the shoreline of Lake Erie, Lake Huron, pushed some of the ice away. But it is worth considering that while I'm recording this video, there's a strong east wind as a storm is blowing in, so it's entirely possible that this ice has once again shifted. And while it might be good to know that Lake St. Clair is frozen solid, and if I'm passing through, I don't need to make a side trip to see what birds are on the water, those daily wind conditions can affect how the ice moves around. So even though it shows open water here as of yesterday, by today it's possible that it's closed up, but still something I like to look at. Ice coverage is a big sort of climate change talk too, so even though this doesn't have to do with predicting birds, I'll show you a couple cool additional graphics that they provide. I think they're updated once a week. But for this week, this is how much ice coverage we've had on the Great Lakes total, so just under 30% of the lakes are frozen. By this date on average, if you average all the years together, we're at about 30% ice coverage. So while you might say that this is average, it's also worth noting how, for as long as we have data for, there are pretty wild year-to-year swings depending on the winter weather that we're getting. So it is pretty normal to have very icy years or very little ice. And this average line isn't necessarily reflective of where it should be year after year. This one, I'll just do this really quick, goes over the accumulated ice for the winter as a whole, as opposed to just at that moment in time. So this one will show you we're a little bit below average, the total percentage of ice cover that we've experienced since ice first started forming on the lakes. And this one is a really cool one too, of that green line, which is the average for the date, changes depending on the date. So if you want to see how the winter has progressed compared to that median mentioned before, we're kind of following the line. This looks remarkably on par. Just keep in mind that there are year-to-year swings in ice coverage. One last kind of neat one is just they even have an average of where the ice is for that date. So certain colors represent more ice buildup than average, and certain colors represent less ice buildup than average. But again, lots of year-to-year variation. Most of what I've just covered there is sort of the forecast stuff that I tend to look at before I'm heading out birding, or if I'm planning my birding over the next 5 to 10 days. I want to talk about that sort of other element of Birdcast, which is the real-time radar and satellite data, before jumping into just some of the other weather tools I use for different reasons. But focusing on radar and satellite, the one I click on all the time is the Wisconsin University NexRad radar system. It is super high resolution. It goes for like the past 3 hours. Right now it's February with a storm, so there's not too much organic material in the air, maybe a bit over Florida in terms of bird or insect movement. This is all rain and snow. There's a lot of websites out there that'll help you decipher the difference between bird, insect data on radar versus rain, snow data on radar. This website too, if you go to their main page, also has different sectors. So I can click on a Great Lakes sector, or Wisconsin, or a Southeast sector, which will zoom in even more and give you even higher resolution on the radar as it's happening. Another radar site that I use all the time is this RapRadar site. The key difference is that I can get radar data over the last 5 days for a longer period of time. So an example of that might be I wake up in the morning and I want to see the entire previous nights of radar. I don't want to just see the last 3 hours. Maybe I'm curious to know, did any birds make it across the lake as I can see them on radar, or was it just rain all night? Sometimes there'll be these narrow windows where birds cross as it's raining or snowing. So having that ability to look backwards is really awesome. But also sometimes I'll come in from the field and I'll say, oh, I had a great day, or there was a big squall that brought in a bunch of birds when I was lake watching. I kind of want to see what that squall looked like on radar, so I can just go back in time and get access to that data really easily with this website. You just have to remember your date is relative, as with all this weather stuff, the universal coordinated time, not your local time zone. So you just got to get familiar with getting the time that it was where you were, not just the UTC time. Canadian radar, there's a link. It's just because the weather beam only goes so far. And if you're well into Canada, like I am, then some of the US stations, even though they're high resolution and they're easy to use and they show you lots of birds on radar, doesn't quite reach into Canada. Unfortunately, Canada does not do a particularly good job of showing you the birds. I think more often than not, or always, the birds are removed from the map, but that's why I have that on there, just in case you want to know where it's raining. And sometimes I find just even knowing where the clouds are, whether it's for photography or like hawk watching with the raptors liking some sun to heat the ground, I will access the geostationary satellite data. I've got this one bookmarked to the Great Lakes, but there are, again, other regions, and I can just sort of see what's going on with the cloud bank. And I can say, is this going to break? Is this solid? Is there a squall line coming that I need to be afraid of? It's just a cool way to view clouds, and even sometimes I'll use it to look at smoke if it's a big forest fire sort of year, just out of curiosity more than anything. So yeah, that's radar and satellite. These next ones are more quirky than anything, but I tacked them on for the sake of completeness. I really like to know where there are storms. Sometimes tornado outbreaks or other severe weather can lead to migratory surges or vagrancy. So understanding where significant wind, hail, tornado threats are can be interesting to know. They have detailed 1, 2, and 3 day outlooks, less detailed, but still interesting 4 to 8 day outlooks. There's a Canadian version, which seems to be hard to access sometimes. And if you are lucky and or definitively unlucky enough to have a hurricane headed your way or hurricane remnants, the National Hurricane Center is far and away the best place for information. I find there's so much hype and so much long-range guessing that goes on with hurricane-related forecasting that it is well within your best interest and sanity to get your information from a source like this rather than other random sites you're looking at computer model data. If you're a sucker for weather punishment like I am sometimes, it can be fun to look at the 3 to 4 week outlook. This time of year, the accuracy is pretty good, even though it's pretty far into the future. Because again, this is created by a human being. And winter weather tends to be easier to predict than spring and summer weather. So unfortunately, as we get into peak craziness in May, our ability to predict weather 3 to 4 weeks out is at its absolute lowest for the entire year. So it's not too valuable then, but looking at this right now sort of gives me some expectation that even into the first week and a half of March, I probably shouldn't be expecting any warm weather in the Great Lakes where I live. I'm going to have to wait a little later into the month before we get our big surge of spring migrants. Another interesting one, this is from one particular researcher. It's not updated all the time, but they've identified North American weather regimes for general patterns that we tend to get, like repeating patterns in our weather and our computer model's ability to predict them. So I won't get into too much detail here. If you're curious, you can look around on the website and find the descriptions. But right now we're in a Greenland high pattern, which tends to bring cold, snowy weather to where we are, which is happening because it's going to be freezing cold here next week after we get a blizzard. And then interestingly, what might catch my eye is that the Pacific Ridge regime is one that I tend to associate with warm air, but also vagrancy in spring and fall. It's pretty, not totally reliable, but it tends to be the regime of the 4 that is most likely to bring birds from the south and southwest. The computer models, at least right now, which are subject to change, are hinting at maybe 3rd week, halfway through the 2nd week into the 3rd week of March, and maybe where I live we have some warm, delightful weather to look forward to. Kind of an interesting one. I think it's sort of a way of like summarizing, not unlike how Birdcast summarizes a lot of complicated weather forecasting and bird forecasting in an easy to use format. I find that one easier to use now than what I used to use, which was like North Atlantic Oscillation Forecast or the Arctic Oscillation Forecast or the Madden-Julian Oscillation, which are all super valuable things to look at if you're a weather forecaster. But each one sort of has its own nuances and how it affects the area where you would live. And these weather regimes just might be an easier way to look at that. Even longer lead times, ENSO, so El Nino, La Nina, can alter weather on a global pattern. So I don't check this very often, but every once in a while I'll be curious to see what the models are forecasting. So here's they're currently in a mild La Nina, which is predicted to wane throughout the spring. Forecast accuracy is fairly low. the further away you get, these are the months. This is August, September, October. But it can have big implications on severe weather in the spring, or especially like hurricane season in the fall. So it is one I like to check. It's also one I like to check backwards on. Sometimes maybe there was a particularly busy fall for a certain kind of birding, and I want to know what the measure was in this ENSO cycle between El Nino, La Nina, and neutral conditions. It goes back to 1950 on the link. And perhaps even worse is this, worse in a, for me, not worse in a forecasting kind of way, but they have these even longer range forecast maps, which is really pushing the limits of what we can do and what we know as human beings trying to understand the weather. So I'm really trying to torment myself. I'll look at an April, May, June temperature anomaly forecast issued from mid-January, just because I like to get my hopes up when it's cold here and we're waiting for the birds to arrive. So to end the page on a high note, I also want to just go over some of my favorite sources for historical weather data. These are the ones I use for the Great Lakes. There will be other options available depending on where you live, but I find it is super interesting to know about a significant weather event that happened in the past and then go back and look at the weather data at the time. I can get surface analysis charts like this back to 1985, and then I can get more detailed information such as infrared satellite or radar images back to 2005. If there's a famous fallout or a famous birding event or a hurricane or whatever that was known for something remarkable happening, it is a really cool learning opportunity to go backwards in time and see the weather as it unfolded. For Canadian weather sites, I tend to go to this climate data online. This one requires a bit of familiarity. I know that there's a weather station in Goderich, Ontario on Lake Huron, near where I like to go birding a lot, but I can get the hourly weather data from that station 5 years ago today, or whichever day I choose, as long as the data is available. By hour, it gives me the temperature, humidity, wind direction, wind intensity, pressure. So again, if you're really getting into the weeds and keen to see what things were like in the past, that's a really great tool for that. The last one being this globe view of earthnullschool.net. It actually has some backwards in time as well as into the future model data from the American numerical model, the GFS, all built into it. So this one I don't tend to use a whole lot, but it's just kind of neat that it has that mixture of going into the future or back into the past. One I do like on this one quite a bit is it gives you more ocean data as well, so you can get ocean currents and sea surface temperatures, both current and back in time. So I know that was a lot, but if you're keen on this kind of thing, I hope you found it interesting or insightful or helpful. If you have any questions, leave it in the video or reach out to me. I'm always keen to talk about weather. And yeah, hope you have some amazing birding. I hope spring doesn't take quite as long as it seems to be taking here, but the birds are on their way. So we'll see you out there.